morning, ladies and gentlemen. As Gengi said, I'm Kumar Joshi. I'm the Regional Account Manager for Netscout in EMEA, and I'm joined today with my colleague Sanjay Radia, the Chief Solutions Architect in EMEA too. I'm going to go through a few brief slides on Netscout and then hand over to Sanjay to do a live demo and show you a use case on our solution. So Netscout are a $1.2 billion company in revenue, and we're listed on the NASDAQ. We have 3,500 employees worldwide, and because of our strong engineering background, at least 35% of them are dedicated to research and development. We're the market leaders in packet collection and aggregation, DDoS, service assurance in enterprise and service provider. So service assurance challenges for IT today, it's about getting to the actual issue and identifying it as quick and seamlessly as possible, keeping the MTTR down, and this equates to cost savings. Manual packet capture is no longer viable. A 5-minute packet capture can consist of up to 3 billion packets. This is unfit for human consumption. With the Netscout solution, we believe we can give you the information that will take you to the root cause issue as quickly and as seamlessly as possible. Top companies around the world trust Netscout. We've been in this niche sector for 30+ years. We serve 90% plus of the Fortune 100, from your top financial organizations around the world to your top service providers. So Netscout's approach is proactive service triaging within 3 clicks using a top-down analysis model. You start off at the very highest level, the service dashboard. This gives you visibility into your critical services and performance issues. 1 click down, you'll drill down to the service monitor that gives you your metrics on all your KPIs, and then drill down to the session analysis. And this more user information, we're giving you hop-by-hop transactional information and latency measurements too. And then the last port of call, should you need it, is going down to the packets as well, which we do. So challenges of the hybrid computing environment today, it's basically too many teams using too many tools. You have server ops teams, network ops teams, engineering teams, development teams. It's basically too many people using too many tools with little automation, if none at all. With Netscout, we have the one tool for many solutions. We support carrier scale as well as enterprise. We do advanced threat detection, data center application assurance, cloud application assurance, network assurance, wireless service assurance, unified communication services. And this is all available over a packet flow framework, enabling IT to deliver high-quality services to the business while reducing costs. So lastly, just giving you an idea of today's application stroke service on your network domain today. It's about a multi-tiered architecture where you have a web front end, some sort of middleware application server, and then a database back end. With the Netscout solution, you'll see we'll be able to pinpoint exactly where the issues are, pinpointing the KPI metrics, and being able for you to do your job as it is today. So with that, I'd like to hand over to my colleague Sanjay, who will be able to go through a live demo of the system on his laptop and talk through a user case. Thank you.
Good morning. My name's Sanjay. I'm the Chief Solutions Architect for EMEA. I'm going to give you a brief overview of the workflows within nGenius One for the purposes of application service assurance, network service assurance, and some security service assurance as well. Netscout Engenius One is very much service-driven. We want to monitor your application services in a multi-tier architecture. As you can see on the screen here, we've got a dashboard which gives you a high-level overview of all of your services. And this can be structured by applications, by region, by both. And you can give your users access to whichever of these tiles you need to. If I drill into one of these enterprise applications, we can see the underlying applications here. And if we look at Oracle, we can actually see the underlying infrastructure. So this shows me that this service is made up of some Oracle RAC servers, there's DNS, there's some Oracle database servers here as well, and we've got a tile for the users in London. Now this immediately shows me that we've got problems, because if I look at the DB Oracle tile, I'm seeing a 23% slow response time issues. So if I click on this, the first thing that customers ask me when I go on site, and it's a challenge for most application teams and for network teams when they're troubleshooting, is, well, how do I know how my application works? When I go and speak to someone in networks and say, how does your Oracle system work? They'll give me an IP address maybe. And they'll say, well, what else does it use? And they're like, I don't know. Speak to the application guys. They can give you some information, and then you have to ask around, and it's very time consuming when you're trying to fix something. So we do this for you. You click on this one, you say service dependency, and we will automatically draw you an application flow map of how we're seeing your applications working. So this is showing you at the very top the users, the user communities coming in. They're talking to some web servers at this second tier. And underneath that, we can see some Oracle database servers and some other bits. Now on here, you've also got some metrics overlaid. So up here, we can see we're seeing errors, 368 errors in the last hour. I can also change this to load, and that tells me what my load balancing looks like. And I can also change it to response time. So if the load balancing isn't right, I'll immediately see if there's an impact on the service response time. And this map's interactive. You can drill into items in here. Now this tells you, the blue servers tell you what it's found from what I've told it. So I've told it I have Oracle protocol on my network. And it's then gone and found the servers and users connecting to it. What it also then says is, I've actually found something you didn't know about. This little d means I found a dependency. And a green server here means these 6 DNS servers are actually being used in this service that you may not have known about. So now I can actually use this to document my application, but also find out what else it's dependent on, which could cause an impact if there's a failure. So we can troubleshoot from here. So we can say, well, let's drill into this DB Oracle tile. Now it knows it's database traffic. We've told it it's database traffic. So we have a specialist database monitor. If you have other types of traffic, we can assign different monitors. We have media monitors and call server monitors for voice traffic. We have certificate monitors, which I'll show you for your certificate infrastructure. We have web, one of the most important ones, the web monitor for HTTP traffic. So if I drill into this and say, take me to the database monitor, we get an overview of the performance of my databases. So all my servers now are listed with their performance metrics as well. So if there's any response time issues, any errors, we would see this. As the packets come past our probing infrastructure, we pick out error codes in real time. So down the bottom here, you can see Oracle no data returned. That's an error code that the user may have seen. And we don't need to ring the user now. We can immediately from here tell what the error code is and pass it to the right team that needs to troubleshoot it. We can also do things like sort by latency, and immediately we can see here we have very high latency on this server compared to the ones underneath it. Average response time here is 556 milliseconds compared to 300 elsewhere. I can't see any errors on there. I can't really see any other issues. So now I can take it to that last mile. This is something that network teams typically did not have access to before. I can click this button here, and it takes me to an overview of the server health. So now I can see what the server's looking like, and I can see actually memory utilization is very high at certain times. If I scroll down, I also, if I want, have access to syslog. So I can actually now, for that server, for that time, pull up the syslog and see if anything happened. Normally, networks would have to ring the application team, and the application teams, in my experience, will tell them to go away and leave them alone. If we look down here as well, it tells us that this is a virtual server, and it's residing on the DC1 Investing 1 hypervisor. So if I click on this, it now shows me the health of the hypervisor. What's the hypervisor looking like? And if I look down here, I see, again, on the hypervisor, memory issues. And it actually tells me virtual machines, 3 of 5 servers on that hypervisor have a problem. And I can click on this, and I immediately see that memory utilization on 3 of those servers is simultaneously going high. So this is something that maybe we need to address the balancing. We need to move those onto another hypervisor where it could have more resources. If I go back to the dashboard, we also have traditional network type tools. So here I can say, show me the utilization of a link. My background is a network engineer, so this is the typical thing everything has to be a utilization problem first. So here now I can see the health of my link, I can see the utilization, and I can see the applications that are causing it. Alternatively, I can switch to the hosts or conversations that are causing that. If I want to know a specific point, I can click here, and it shows me what caused that spike. Now, my background when I was a network engineer was in banking, so 5 minutes is too long. It's far too much. So I can now drill down, and I can say, show me the utilization at 15 seconds. Well, then it's around 23 megabits per second. Let's drill in further. 1 second, starting to go up. Let's pick a point here, and we can keep drilling down. Until I get to 1 millisecond. So now I can see, I'm actually seeing spikes of up to nearly 450 megabits per second. So this is something that could be an issue. It could overrun buffers and things like that. On an average link utilization, it didn't look so bad. But here we can see there are problems. We also then have Threat Monitor. So this is a new tool that puts a security workflow on our instrumentation. So it's the same collection engines, but with a different workflow. We are now picking out volumetric, state exhaustion, and application layer attacks. So this is where we can now see if there's issues going in on our servers where they're under attack or having some issues. And this is a new workflow that was added in after our merger with Arbor. Another security workflow we have is Certificate Monitor. So here I can say, just show me all my certificates on my network, everything. Here I can see on this one, I have 42 critical certificates. What that means is I'm seeing issues where they're about to expire. And I can set that threshold. I can say, well, it takes me typically 2 weeks to order a certificate, get it installed, get a change in. So I want 30 days notice so that when it's about to expire, I get enough warning. So I can set my alarms and I can run reports on this regularly. And this will then tell me that actually I've got certificates that are due to expire and I need to renew them. It also tells me the cipher on them. So if there's any old certificates, here we've got some 1.0, we need to go and find those, address it. They shouldn't be on there. Maybe it's against company policy to have self-signed certificates. We pick those out as well. So if there are any self-signed certificates here, we can also look at those. Now, one of the other workflows we have when we're drilling down into things for performance is looking at things from an application perspective. So here we've got Database Monitor. So it shows me the connections, queries, modifications, and things like that. As a network engineer, that doesn't really interest me so much. As an application or a database administrator, it probably will do. So here I can then drill into some more workflows that are useful to me. So I can say, actually, give me a universal workflow. So this now shows me response times, TCP response time, application response times, client response times. It also then allows me to drill into one more low-level view, which network engineers use quite a lot. My resolution's gone. There we go. This is the TCP analysis view. So this now gives me things like, am I having problems with 0 windows? Am I having problems with window sizes? Am I having problems with anything else that's TCP related, maybe not application related? Now, when we see the packets coming into us, as well as recording them, we generate a huge amount of metadata. So this data is stored in a database. You can go back in history and have a look at performance metrics and utilization and that sort of thing. But actually, we also generate packet-level metadata. And what that does is it allows you to go to information that you would typically have to go to a packet trace for. We don't want you to go to packets. It's far too time-consuming. In 40, 100 gig networks, it's just not practical to do a 1 or 2 minute data capture because the amount of packets you get is just massive. So what I can do is actually say, well, this service saying users had issues. We've got error codes. Drill into the session records. Show me which users had issues. So this now talks to the instrumentation, and it pulls those records, almost like call records in voice monitoring. So here now we see a session analysis of an individual session. We have a full transactional diagram. And we have lots of information about the error codes, the database that was connected to, and things like that, and the failure state. We also have some TCP metrics. And you may want the packets for this. Someone may say, well, can you send me a packet trace to look at? You click here, and it will pull the packets from the probe for you. And you can save these off and send them out as generic standard PCAPs. One of the other workflows we have that came through an acquisition of a company called Cytechnics, which was part of British Telecom, is voice monitoring. We have very in-depth voice monitoring. If someone rings you and says, well, I've got a problem with a call, this was the number I dialed, or this is my extension, then you can immediately troubleshoot it by just simply putting it into your call search. So here I can say, well, I just want to look at all voice and video. The extension I'm interested in is 7777. And it pulls a list of calls that extension has had to and from. So here now I can see the calls. I can also see the health of those calls. So if I pick one of these, one that went over an SBC, I can say, well, I want you to look at the individual call record for that. So now we have a hop-by-hop view of the call across Dallas to San Jose, and we have the SBC it went over. We can then say, well, what happened? So it says you had loss and jitter, and you had a course mismatch. So we can say, well, what was the course queues that got mismatched? So here we can see it started at 34 and got bleached out to 0. So there's the problem. You need to start looking at something on your router configuration, maybe. So this immediately helps you highlight issues that may be occurring. That's the end of my demonstration. I'll hand you over to Gengi. But if you have any questions, please do visit our stand, and we can go into further detail on our demo or answer any questions you may have. Thank you.